My name is Jay, and I'm the team lead and the programmer.
Hello, my name is Grace, and I'm the editor and designer.
Celena, and I'm the designer for this group.
Hi, my name's Eric, and I'm the assembler.
The purpose of our device is to monitor the respiration rate of young infants, particularly those with respiration problems.
This device makes sure that these babies are breathing properly and at an appropriate rate. It is especially useful for when an infant's respiration rate enters an abnormal range.
Due to error, humans have a harder time quickly, accurately, and conveniently assessing respiration rate compared to machines. This device allows faster response times when issues arise.
We found that the lungs are one of the last organs to develop in utero. Because of this, a lot of premature infants have respiratory problems and may need assistance in their breathing. Parents need and want assurance that their newborn baby is breathing properly. To combat this issue, we created a device that would count the number of breaths the baby takes in a minute.
After thinking hard about the problem at hand, our team thought of a few ideas that could help these parents and newborns with this problem. We brainstormed ideas such as building a permanent stethoscope and chest movement sensor. We later decided that a movement sensor would be best because a child crying and screaming would hinder the proper use of a stethoscope.
Initially, we had the idea of tilting the playground circuit to detect movement. We would have it lay on the chest, and when the baby took a breath, the tilt would indicate to the console that a breath had been made. After a few attempts of using the tilting method, we decided to develop a new device code that would use light as a counter. Every time the baby breathed, the movement would trigger a light to turn on, and the playground circuit would register that flicker of light as one breath.
Our first idea, the tilting mechanism, was too impractical. We immediately encountered a problem where the playground circuit could not detect movement. Our second idea stemmed from our first, where we still use movement except to complete a circuit. The circuit would turn on a light sensed by the playground circuit, which would then count a breath. Our third idea also involved light, but utilized a counter within the code. The playground circuit lit up when sensing movement and then counted the light as one breath.
For our final device, we decided to go with the simplest mechanism to minimize the magnitude of errors that may occur with too many components. When the device senses movement, it counts a breath.
Finally, we used what we had and further improved the code to allow the playground circuit to depend on itself and increase the accuracy of the counter. We also created a harness that would hold the circuit in place on the baby.
The device had to be a practical size as we were dealing with newborn, potentially premature infants. Along the same vein, the device had to be comfortable and easily fitted onto an infant's body, both for the baby's sake and the parents'. Lastly, the harness was created to go either around the infant's back or around the arms, to be usable when the baby is both swaddled and unswaddled, respectively.